Hello and welcome to this episode of SPSS one-on-one series with Warrior Analytics. Today we look at factor analysis, a method used for data reduction. You have got a lot of variables, but you want to establish the underlying structure. Which of those variables are closely related that can be grouped together into what we call factors. In this episode, we have got hypothetical data that we are going to use for this demonstration. The link to the data is in the description of this video. You can download for your practice. So in this data set, we have got 10 variables. These 10 variables are obtained from a study that is aimed at understanding employee perceptions of teamwork and job satisfaction. It is a survey that collected data using a Likert scale from 1 for strongly disagree to 5 for strongly agree, with a total of 500 participants. Instead of us analyzing these 10 variables individually, which would have little meaning for us in answering our question, we would decide to use factor analysis to group these variables into factors or groups of related variables that can help us explain the variations in our study. As usual, for any analytical procedure that you're going to use, there are procedures that you have to follow. In factor analysis, we shall start by checking for suitability of our data for factor analysis. Then, we shall check for the assumptions for factor analysis. These two are related. Then, we run our analysis and interpret our findings. When checking for suitability of our data for factor analysis, there are several steps we shall follow. One is checking data for consistency. We've seen in our data that we use the Likert scale of 1 to 5. So all of the questions should have coding in the same direction. 1 for strongly disagree and 5 for strongly agree, if that's what you've chosen. We don't expect to have some questions, other questions reverse coded, where a 5 means strongly disagree. No. Make sure all the data coding is in the same direction. And also, you should have cleaned your data. You don't have out of range values. We would expect our data to only have values between 1 to 5. We don't expect to see a 0 or a value above 5. Unless those values have been specified in SPSS that maybe they are missing values. Next, we check the sample size requirements. Usually, a sample size of about 300 is considered adequate for factor analysis. Others recommend at least 5 to 20 cases per item or variable you're going to include. If I have, say, 50 variables, I would be expected to have 50 times, say, 5, a minimum, okay, to give me the sample size I should be working with. In our data set, we have 500 and we have 10 items. So literally that is about 50 cases per item that we are going to put in the analysis, which is good enough. Third, we have to check for the strength of relationship among our variables. In factor analysis, we are looking for groups of related variables. First of all, your data has to be related in some way or the other. To check this, we shall use a correlation matrix to establish whether there is a relationship. And we shall be looking for a correlation coefficient of 0.3 and above to show us that the variables in our data set are related. And lastly, we shall also perform statistical tests to show that actually our data is fit for factor analysis. And here we shall be using the Bartlett's test of Sphericity and the KMO test of sampling adequacy. Before we go to practically check for suitability, I want us to also look at the assumptions, because the suitability and assumptions are actually moving together. We have got 3 assumptions whereby there should be a relationship among variables, the one which we shall run using a correlation matrix, and that relationship should be linear, which is the test for a correlation, tests for existence of a linear relationship. Then the sample is homogeneous with respect to underlying factor structure. If you are to use factor analysis, ensure that you do not have variables which would influence the way the factors are extracted. For example, if you think gender may affect which factors are extracted for males and females, then it is better you split your data according to gender and do analysis for males separately and for females separately. So let us check for suitability in our data set. To do that, simply go to Analyze, go to Dimension Reduction, and then click on Factor. In Factor, we are going to put in all the items that we want to analyze using factor analysis, and we put them in the variables box. Then under descriptives, we are going to check correlation coefficients, significance levels, determinant, and then KMO and Bartlett's test of Sphericity. Click continue and then OK. In our output, we have the correlation matrix. We are interested in a correlation of at least 0.3 and above between the items or questions. So here we can see we have 0.745 between item 1 and 2, item 1 and 3 to 0.739, and we have others. So once you at least have a value above 0.3, you are sure that there is a relationship between variables in your data set. Next, we have the KMO and Bartlett's test. The KMO, the Kaiser-Meyer-Olkin measure of sampling adequacy, ranges between 0 to 1. But usually, if you have values of 0.6 and above, that is considered adequate. What the KMO is actually telling you is that there is enough variance in our data that we can partition it using factor analysis. Then we look at the Bartlett's test of Sphericity, which is actually testing whether your correlation matrix is significantly different from the correlation identity. So what we are interested in is a statistically significant value, which indicates that our data is fit for factor analysis. Those are the two outputs that we are interested in to determine whether our data is fit for factor analysis. So next we shall look at how do we run the analysis. To run the analysis, we first extract the factors, those groups of related variables, and then we rotate these factors for interpretability. Each of these steps, there are several methods involved, but let us go into SPSS and see. So to run the actual analysis, still we go to Analyze, go to Dimension Reduction, and click on Factor. We have already put the variables in there. Descriptives, yeah, we no longer need the coefficients, significance, determinants, and KMO because our data has already passed. Continue. Under extraction, we have different ways of forming those groups or extracting those factors of related variables. And when I click on here, you see that we have several, but the most common ones are principal components and the principal axis factoring, which is the common factor analysis. Whenever someone talks of factor analysis, this is what it is referred to here as principal axis factoring in SPSS. To understand which one to choose among these two, the principal components and principal axis factoring, we are going to look at our PowerPoint for explanations. But before we head there, I want us to first go to rotation, because these two methods move hand in hand. We extract and you rotate, because the method of rotation also depends on the method of extraction. So under rotation, we have got here several methods as well, but broadly categorized into two. The orthogonal, there are these three, which assume that there is no relationship between the factors that are extracted. Then we also have the oblique approaches, which assume that the factors extracted are related in some way. So let us see what is extraction and rotation. So under extraction and rotation of factors, we have got two methods for extraction, and that is the principal component analysis and the common factor analysis, the usual factor analysis, which in SPSS is being called principal axis factoring. The choice of method that you're going to use depends on what is the purpose of your analysis. When we look at the common factor analysis, it is used when the goal is to find the underlying latent constructs and nothing else. You just want to know, of these 10 variables, how many groups can be made of related variables. For example, if we are interested in understanding employee perceptions of teamwork and job satisfaction alone, we just want to know which are those constructs that underlie our structure, our data set. We shall use the common factor analysis. But if our goal is to summarize all of those variables into the minimum number of factors for using in further analysis, then we shall use the principal component analysis as the extraction method. In our example, if we wanted to understand the effect of employee perceptions of teamwork and job satisfaction on performance, we want to get the structures and then use those new factors as new variables for our further analysis to establish the relationship with performance. Then we shall use principal component analysis. Regardless of which method you've used, you need to rotate those factors. Rotation of factors is simply a technique used to enhance interpretability of factors by simplifying their structure. You want to make it easier for you to interpret those factors in a logical sense. So methods have been made available for us to use for rotation. And still, these methods of rotation depend on what is the goal of your analysis. We have orthogonal methods of rotation. The Quatermax, Varimax, and Equamax, they have slight variations in them. You can try to find out. But these ones are used still when the goal is to summarize most of the information so that you have fewer factors that you can now use for further analysis, maybe for regression. For you to use orthogonal for rotation, then you should have used principal component analysis for extraction. So principal component moves together with orthogonal. These orthogonal methods assume that the factors, the groups being extracted, are not related to each other. Meaning, this method is suitable when you want to extract those variables for example, use for logistic regression, because it eliminates collinearity in your future analysis. On the other hand, we have oblique methods, which assume that factors you are extracting, those groups of variables you are extracting, are related to each other. So these ones are used when the goal is just to find underlying structure. You're not worried about the collinearity which may come if you are to use those extractions or those factors for further analysis. So for you to use oblique methods, you just want to understand underlying structure, no further analysis, and you should have used common factor analysis or the principal axis factoring for extraction of the factors. In the social sciences, you find that this is the most common method of rotation and extraction because in reality, the groups of variables being extracted or the factors are related. So in this particular episode, we are going to use the common factor analysis or the principal axis factoring with the oblique methods of extraction, because we just want to determine the underlying structure. We don't intend to use it for further analysis. We said we got to analyze dimension reduction factors. The factors are already there. For the descriptives, we said we are no longer interested in this. Continue. And then under extraction, since our interest is just to get the underlying structure, no further analysis, we are going to use principal axis factoring. In this, we are going to ask for the script plot. For extraction, we are going to base on eigenvalues greater than 1. We click continue. Then under rotation, we are going to check the oblique methods. We are going to use direct oblimin and then click continue. Under options, we are going to sort by size and then suppress small coefficients, then continue and click OK. So this is our output where we have our communalities, we have our total variance, we have a script plot, we have the factor matrix, but we interpret the pattern matrix. So in our next episode, we are going to look at how to interpret results of a factor analysis in SPSS and how do we report results for our final analysis. If you find these videos helpful, consider liking and subscribing to the videos. I'll be grateful. In case you have any questions, feel free to leave them in the comment section. See you in the next episode.